This lesson is compute the determinant. Here we have a matrix with a 3 by 3, and we're going to use the cofactor expansion method. So this is a 3 by 3 using cofactor expansion method. So the first thing we need to do is take this 3, put it here. Take this 3, put it here. After that, you will block out the first row, and then block out the first column, and then you will have left is 3, 2, 5, negative 1, and then you will put it here. One more time, you will take the 3, put it here. One more time, take the 3, put it here, and then block out the first row, first column, and all you have left is 3, 2, 5, negative 1, and put it right here. Repeat that method, repeat that procedure all the way through the first row. One more time, repeat that all the way to the first row. Okay, so the first one is 3, the next one will be 0, but you need to put a minus. Okay, so first row, block out the second column, all you have left is 2, 0, 2, negative 1, which is here. Okay, next, same thing, you're going to take this 4, put it here. Since this is a minus, now become plus. So take the 4, put it here. Block out the first row, block out the last column. You have 2, 3, 0, 5, and you put it here. One more time. You will start here, take the 3, put it here. Block out the first row, block out the first column. You have 3, 2, 5, negative 1, put it here. Next, it will be 0, put the 0 here. Since the first is positive, the next will be negative. So 0 over here. Block out the first row, block out the second column. You have 2, 0, 2, negative 1, which is here. Next, you will take the 4, put it here. Since this is a minus, the next one should be a plus. So take the 4, put it here. Block out the first row, block out the third column, 2, 3, 0, 5, which is here. Okay. After that, you will do the determinant for a 2 by 2. If you remember from previous lesson, 2 by 2, we just do A times D minus B times C. So 3 times negative 1, which is here, always minus, 3, negative 1 right here, always minus, and then 2 times 5, which is here. Go on to the next one. I know this is 0, 0 times everything is 0, but I'm still going to go through the process so you can see the A times D minus B times C. So A times D, which is here, minus 2 times 0, which is here. Next, 2 times 5, which is here, minus 3 times 0, which is here. After that, just simplify. This is negative 3. This will be negative 10, so it gives me negative 13. Negative 2 times 0 will be negative 2 here. This is negative 10, 0, so 10 subtract 0 will be here. 3 times negative 13 will be negative 39. 0 times negative 2 will be 0. 4 times 10 will be 40. Negative 39 plus 0 plus 40 gives me positive 1. So the determinant of this matrix is positive 1. One more time. This is called a co-expansion method. So this is what we will do. You will start with 3 and put it here. Since this is the starting point, it is always plus. Take the 3, block up the first row, block up the first column, and then whatever you have here, you will put here. Okay. Next, since this is a plus, you will alternate plus, minus. So next will be the 0. Block out the first row, block out the second column. You will have 2, 0, 2, -1, which is here. Next, since this is a minus, alternate, so it become plus. The next one will be a 4, put a 4 here. Take the first row, take the last column, and you have 2, 3, 0, 5, which is here. And then after that, do the determinant of a 2 by 2, A times D minus B times C. And you do the same thing with the rest, okay? And then after that, just simplify, and it comes out to be +1. Now, what I did here is I use row 1, column 1. Technically, you can use any rows, any column. It will be the same outcome. One more time, if I do row 2, column 1, it will still come out the same result, which is +1. I purposely do the first row so you get the idea of co-expansion. With co-expansion, you can do any rows, any columns, and the result will be the same answer. Okay, so this is called the co-expansion method. The next method, which is called the basket weaving. So this is what you will do. You will take the first column and the second column and just copy it over to the right side. Take the first column, the second column, rewrite it to the right hand side. Okay, so first column here, second column here. After that, you will start from the left side, the left. So 3 times 3 times -1, which is here, plus 0 times 2 times 0, which is here, plus 4 times 2 times 5, which is here. Always start from the left and go down diagonally. Okay, and there should be 3. Okay, and the reason why there's 3 because we are in 3 by 3 matrix. After that, always minus, and then from left, now go to the right side. So here's the right side, 4, 3, 0, which is here, plus 3, 2, 5, which is here, plus 0, 2, -1, which is here. Again, this is called a basket weaving. Take the first column, put over here. Take the second column, put it here. Start from the left, and then you should have 3 minus, always minus, and then go to the right. There should be 3 of them, which is here. After that, just simplify. So this gives me -9, 0, 40, minus 0. This right here gives me 30, and this gives me 0. -9 plus 40 will be +31, and then minus times 30 will be -30. 31 subtract 30 gives me 1. Again, this is called a basket weaving, and as you can see, they will have the same result. If you use the cofactor method or basket weaving method, will come out the same result. However, be very careful. The basket weaving only work for a 3 by 3. It does not work for a 4 by 4, 5 by 5, or anything higher than 3. So be very careful. Basket weaving only work for 3 by 3. Anything bigger than 3 by 3, it will not work. Now the last method is called the row operation. Okay. The row operation. So I've shown you 3 methods. I'm going to show you 3 methods. The first method was called cofactor. The second method is called basket weaving. As you can see, same result, but be very careful. Basket weaving only work for 3 by 3. And the last method is called the row operation, which by now you should know how to do row operations. Okay, So when you do row operation, this first term right here don't have to be a 1, okay? Because we are looking for determinate. Since we are looking for determinate, this right here doesn't have to be a 1. This 3 right here doesn't have to be a 1. We can leave it alone. So we need this 2 to be a 0. So we need to multiply the reciprocal of 3. Take the 2, and since this is positive, we need a negative. So that's where I got the negative 2/3. One more time. We need this 2 to become a 0. So reciprocal to 3, which is 1/3. Take the 2, put it here, and since this is positive, make it a negative so I can subtract. Okay? So here, negative 2 times 3, which gives me negative 6. Negative 6 divided by 3 will give me negative 2. Negative 2 plus 2 will give me this 0. One more time. 3 times 2 gives me 3 times negative 2 will give me negative 6. Negative 6 divided by 3 gives me negative 2. Negative 2 plus 2 gives me this 0. Next, negative 2/3 times 0 is just 0. 0 plus 3 will give me this 3. Next, negative 2 times 4 will give me negative 8/3. Okay, so negative 2 times 4 gives me negative 8, but I have a 3. So here I did the math, the fractions. So I hope this will help you to remember how to do add and subtract fractions. So 4, negative 2 gives me negative 8. Don't forget the 3. But we're adding the we're adding the 2, so 2/1. So adding and subtracting fractions, you will do cross multiply. So negative 8 times 1 gives me negative 8. 2 times 3 gives me negative 6. And then you will under multiply. So 3 times 1 gives me 3. Now just add the top only or subtract. So negative 8 plus 6 gives me negative 2/3. So that's where the negative 2/3 came from. One more time. 4 times negative 2 gives me negative 8. Don't forget the third. The 3 in the bottom. And then add 2. So we'll put a 1 underneath. Now adding and subtracting fractions, you can cross multiply. So negative 8 times 1 is negative 8. 2 times 3 gives me 6. 3 times 1 gives me 3. Add or subtract the top. Negative 8 plus 6 gives me negative 2. So negative 2/3, which I have here. Okay. Next, if you notice something, this is already a 0, so we just leave this alone. Okay. So all we did was we changed row 2 and leave the first row and the third row alone. This is a 0, so we don't need to change. We'll leave that alone. Next, we need this 5 to be a 0. We need this 5 to be a 0. So we'll do the same procedure from the first time when we're trying to get rid of this 2. So reciprocal this 3. So 1/3. And we're going to take this 5, put it on top. And since this is a plus, we'll do minus 5. One more time. The only way for this 5 to become a 0, we're going to reciprocal this 3, which is 1/3. Put the 5 on top. Since this is a plus, we put the negative in. So negative 5 times 3 will give me negative 15. Negative 15 divided by 3 will give me the negative 5. Negative 5 plus 5 gives me this 0. One more time. 3 times negative 5 is negative 15. Negative 15 divided by 3 gives me negative 5. Negative 5 plus 5 gives me this 0. Next, we will do negative 2 times negative 5, and then 3 times 3, which I have down here. So negative 5 times negative 2, which is here. 3 times 3, which is here. And then add negative 1. So one more time, negative 2 times negative 5, which is here. 3 times 3, which is here, plus negative 1. Okay, so just basic simplify. So negative 2 times negative 5 gives me positive 10. 3 times 3 gives me 9. And then do the same procedure for adding, subtracting fractions. Cross multiply. 10 times 1 is 10. Don't forget the minus. 9 times 1 is 9. And then 9 times 1 is also 9 in the bottom. Now add and subtract the top. 10 subtract 9 gives me 1/9. So I put 1/9 here. Okay. And as you notice something about this last matrix, this last form, does this look very familiar from previous lesson? That this is the upper triangle in LU factorizations. Again, does this look familiar with LU factorizations? Once you get to this form, do not worry about this 0, this 0, this 0. We could ignore these 3 zeros, and we're just going to multiply the diagonals. Just multiply the diagonals. So 3 times 3 times 1/9, which I have here. So 3 times 3 gives me 9. 9 times 1/9 is also 1. So as you can see, row operation still give you the same results. One more time, with row operations, this 3 or whatever this is doesn't have to be a 1. These 2 needs to be a 0. This one has to be a 0 so that I can get to this form where I have 0, 0, 0. Once this 3 is 0, this 3 spot here, here, and here are 0, then we just multiply the diagonal, and I get the same result. Okay, so I have shown you 3 methods to get the determinant using cofactor, using basket weaving. Now be very careful with basket weaving. It only works for 3 by 3. And the last method, which is called row operations, and they still give you the same result. Okay. However, later on, if this matrix is 4 by 4, 5 by 5, cofactor is too lengthy. It takes too long to find the determinant, because the bigger the matrix, the longer it takes to find the determinant using cofactor. Also, if you use basket weaving on a 4 by 4, 5 by 5, anything bigger than 3 by 3, the answer will not be the same. So it doesn't work for anything bigger than 3. So the easiest way or the best way to find the determinant for any square matrix bigger than a 3 by 3 is best to use row operation. One more time, anything bigger than 3 by 3, the best way is to use row operation, because it's much a better method than using cofactor and basket weaving. Okay, so again, row operation would be the best method for 3 by 3 and anything that's anything from 3 by 3 and up.